In this lesson, we're going to introduce the entity relationship model, with which we can make entity relationship diagrams.
We saw several data issues in the last lesson that can be addressed by applying the entity relationship diagram. The entity relationship model or diagram was developed by Peter Chen at Louisiana State University as a way of modeling relational algebra as it's applied to data storage. When he was at IBM, Ted Codd discovered that relational algebra could be applied to data modeling. It is this relational algebra and the entity relationship diagram for modeling it with data that continues to support relational databases today. So what are the components of a relational database? We talked about the importance of the components of a mini world and described different database schemas. Today we're going to formally introduce the concept of a construct in a schema. The four key components of an entity relationship diagram are the entities, attributes, relationships, and the cardinality of the relationships. For this week's project assignment, you will use Lucid Chart to construct an entity relationship diagram. We'll see an example of how that works here. Make sure that you get the student Lucid Chart account so that you can have unlimited documents. The link is provided here. An entity is a construct about which we want to store data. These are the nouns in the mini world. For example, a person, place, thing, or event. An entity should have more than one instance and more than one attribute. On the right, we can see the way to model an entity using a rectangle. Here we have two entities, student and professor. Each entity has a unique identifier that we refer to as a primary key. If you've worked with database management systems before, you've likely seen this ID. A primary key is an attribute or set of attributes that can be used to uniquely identify an individual instance. So the entity itself is not an instance, it's merely a blueprint for any record or instance that will be stored in the database. For example, we have a blueprint for a course here that contains a course number and a course name, and then we have several instances of each course. Notice the primary key is unique on each one. We also would like to store characteristics of entities. We call these attributes. For example, here we have a professor entity with 4 different attributes: a professor ID, a first name, a last name, and a house. The primary key, which is underlined, is also an attribute. After we've decided what we want to store in the database and the characteristics of each thing we want to store in the database, we can decide what the relationships are between those entities. For example, how many courses does a professor teach? How many professors teach one course? It's important to think about the relationship from the perspective of each entity. To represent a relationship, we connect the two entities with a line. What you're seeing here is called crow's foot notation and indicates that we have what's called a one-to-many relationship between course and professor. We'll explain that momentarily. Here's an example of a simple entity relationship diagram. It has two entities, course and professor. Notice that each entity has different attributes, and the primary key, or the unique identifier of the entity, is underlined. The relationship is indicated by a connection between the entities. The only piece of information that we haven't yet addressed on this diagram is what's referred to as the cardinality. This is what defines the relationship. In order to decide on cardinality and represent it, we ask the question from both sides of the relationship. For a particular course, like in the Harry Potter example, Defense of the Dark Arts, how many professors can teach that course? The crow's foot notation represents a many relationship with a crow's foot on the many side. From the opposite perspective, we can ask for a single professor, how many courses will they be teaching? And it does depend upon the business case. A professor will only teach one course. I'd like to pause here just to emphasize that the diagram is really dependent upon the characteristics of the mini world. So even if it seems intuitive to model a relationship one way, you really have to go back and think about exactly what the business needs are.
If you're following along in the textbook, you'll notice that the notation used is a little bit different. The textbook is using Chen's original notation. We're going to use the crow's foot notation, which effectively communicates the same information because it's a little more compact and similar to what you'll see in the modeling tool. After you've established what you want to store information about, in other words, the entities, and the characteristics that you're interested in keeping track of, or the attributes, and you've set up which entities are related to which other entities, it's time to decide the relationship cardinality. In the textbook, you'll see that cardinality is indicated with numbers, but again, we're going to use the crow's foot notation here. Cardinality indicates the minimum and maximum number of occurrences of one entity for a single occurrence of the related entity. We have three basic types of cardinality when it comes to indicating the maximum number of occurrences. The first is that of one-to-many. So in the Hogwarts case, we have that a professor may only teach one course, maximum, but that a course can be taught by many professors, maximum. This sentence does not address the minimum cardinality. The second maximum cardinality type is one-to-one. In this case, during an appointment, a doctor sees only one patient, and a patient is seen by only one doctor. The last maximum cardinality type is that of many-to-many. So in this case, we have that a student can take many courses, and a course can have many students, maximum. Again, notice that the minimum cardinality is not addressed here. Let's take a look at an example of the crow's foot notation for a one-to-many relationship. The maximum cardinality is indicated by the sign that's closest to the entity. So for example, we have that a course can be taught by a maximum of many professors. So looking from the course side to the professor side, a course can be taught by many professors. We indicate many on this side with the crow's foot. Similarly, on the other side, a professor can teach a maximum of one course. If we follow over from the professor to the course side, we have a maximum of one. The symbols on the inside indicate the minimum cardinality. This will change depending upon the business story. In this case, when it's stored in the database, the course has to have a professor. We represent this minimum cardinality of 1 on the inner part of the relationship. In your textbook, you would see that this is indicated by 1, n. On the professor side, we see that if a professor is in the database, that they don't necessarily have to be related to a course. Hence, we have the open circle. So again, from the professor to the course side, a professor doesn't need to have a course, but they can teach a maximum of only one course. In your textbook, you'll see this indicated as 0, 1. From the course perspective, a course has to be associated with a professor, and it can be associated with many different professors. We'll come back to this note in a minute. For now, what I'd like you to understand is that you can look from one side of the relationship to the other and decide what the minimum and maximum cardinality for each should be. So again, how many professors for a particular course? Minimum, maximum. How many courses for a particular professor? Minimum and maximum. Here's an example of a one-to-one relationship. During an appointment, a doctor sees only one patient, and a patient is seen by only one doctor. So here from the patient side, we ask, for a one patient instance, what is the minimum and maximum number of doctors that they should see? If a patient's been put into the system, it's likely in this case that they've been associated with a doctor, so the minimum cardinality would be 1. At this particular hospital or doctor's office, a patient will only see one doctor. And again, it depends upon the story that you're given. Thus, we have a minimum 1 and a maximum 1 from patient to doctor. If we take a look at the other side, if a doctor's put into the system, they don't necessarily have to be assigned a patient. So we have the optional case here. So a doctor would have a minimum of 0 patients and a maximum of only 1 patient. If we're given this type of relationship and we think about what it might mean more closely, we need to consider what this actually means. Is this ERD given to us to represent an appointment time when a doctor sees a patient, or just that a patient is associated with a doctor? In this case, we're told directly that during an appointment, a patient must see a doctor, but a doctor doesn't necessarily have to have a patient. Perhaps they have that hour off. We'll come back to this note again in just a second. The last general cardinality type is that of many-to-many. Here we have an example of a student can take many courses and a course can have many students. What's the minimum and maximum cardinality on each side? What we have here is from the student perspective, if a student's in the system, they have to have a course, and they can have a maximum of many courses. If a course is in the system, it doesn't necessarily have to be related to students, but it can have a maximum of many students. In the last reflection, I gave you this example of a pet shop ERD and asked you to think about, if given a customer first name, if you'd be able to find the price of a product that they'd purchased. This diagram probably makes more sense now, as you can recognize each of the primary keys and see the other attributes of the entities and their relationships. We're not going to be using Microsoft Access, but if you do see it in your travels, you can see that vendor and product have a one-to-many relationship. The point of the reflection was to think about the relationship between entities. For example, if we have a vendor and a product, notice that the vendor ID is connected to another vendor ID in the product entity. This is what we call a foreign key. A foreign key is an attribute that serves as a primary key in one entity and a foreign key in another, where it doesn't uniquely identify an instance of that entity. So in this case, if we have a product, we can determine by using the foreign key what vendor provides that product. There's a simple set of rules to follow when determining which entity receives the foreign key. In the case of a one-to-many relationship, the primary key on the one side becomes a foreign key on the many side. So the course number would be inserted as a foreign key on the professor's side. That way we could easily look up a professor and see which course they were related to. In the case of a one-to-one relationship, which primary key becomes a foreign key? We have to think about which entity is required in the relationship. Here we're given an appointment with a doctor and a patient. A patient must see a doctor during an appointment time, but a doctor does not necessarily have to see a patient. If we think about it that way, the patient must have a doctor ID. So the primary key on the required side is received as a foreign key on the optional side. What about the many-to-many case? Hopefully in the reflection question, we're a little bit primed for thinking about how this works. If we take the primary key from the course side and put it on the student side, we're going to end up with duplicates. The same is true for taking the student primary key and putting it in the course table. If we look back at the example in Microsoft Access, we can see here that what we have is a many-to-many relationship between customer and product. How is this represented? You can see that we have an additional table that's come off called product customer. We could have also called it customer product. This new table has what is referred to as a composite primary key of both the customer ID and the product ID. Here's the corresponding result for a many-to-many relationship between student and course. We have an intersection entity called student course that has a composite primary key of both the student ID and the course ID. Think about the significance of having a composite primary key. If we return to the definition of a primary key is an attribute that uniquely identifies every single record. We need both pieces of information that a particular student is taking a particular course in order to uniquely identify that record. Test it out again in the doctor and patient example from the Excel workbook from last class and you'll see what I mean. You've now had an introduction to the entity relationship model, complete with entities, attributes, relationships, and cardinality of relationships. At this point, check out the example and lucid chart provided on Blackboard.